All right, section 3-7. This is called sequences and equations. All right, so what we have here, if you're on the first page there, it gives you the sequence of numbers 20, 30, 40, 50, and 60. And the one thing I want you to see here is that the numbers go up 10 every time, right? So you're adding 10 to get to every number. It's the same pattern every time. And so since you're adding the same number every time, we call that an arithmetic sequence. So arithmetic is by adding or subtracting the same amount every time. And the example down here at the bottom, this is not in your book, but an example of 1, 4, 1664. The pattern there is multiplying by 4 every time. And I just want us to understand that that would not be an arithmetic sequence. We actually call that a geometric. All right, so because they go up 3, and then they go up 12, and then they go up 48. So it's going up a different amount every time, but it does have a pattern of multiplying. That's just not an arithmetic sequence. It has to be adding or subtracting to be that. And example 1, you can see that there. The pattern is 4, 8, 12, 16. And what they're wanting you to do is just describe the sequence using words or symbols. It's pretty simple, guys. The sequence is just to add 4. So you could say plus 4. You could say add 4. You could say, well, it's an arithmetic sequence since it's adding 4 every time. But that's just a way to describe it. Guys, those are easy questions, so don't make those too complicated. Now if we look on page 159, we have example 2. So example 2 has a sequence of 7, 10, 13, 16. And what I would like you to do is kind of like what's in the book. We want to create this into a table. All right? So we're going to say that this is the first term, second, third, fourth terms, all right? And what this is asking us to do is to find the 15th term, which means if I kept going here, right, I would go all the way to 15. I would find whatever number the 15th number is. Now, obviously, most of you are going to say, well, all I got to do is add 3 every time and just eventually get to 15. And you're correct. That is a way to do this, but I will tell you it's not a way that will work every time for you based on how much time it'll take. So here's what I want you to do. This is asking you to find the 15th term, but what we're going to do is we're going to use this with an equation. So I want you to write down y equals mx plus b. It's basically a formula. All right, so the formula, we're going to put a number in for m, and we're going to put a number in for b. All right, m in this case is this number that you can see that we add or subtract every time. What is the pattern? It is adding 3. So since it's a positive 3, m is 3. If it was going down, say 5, and then down 5 again, just subtracting 5 every time, then we'd put a negative 5 there. But that's the change, all right? So the common difference between each, m becomes 3. Now, since I said this is a formula, m and b are the numbers that we're going to find this formula. All right, we're using the formula to create an equation for this sequence of numbers. And what b is, so m is your common difference, b is your 0th term, 0th term. All right, just like up here, you've got the first term, you've got the second, the third, the fourth. What I'm asking you to do is, what's the 0th term? In other words, what number is right here? Well, if you're going up 3 to get to each of these, you would go back 3. So that term would actually be a 4. So the 0th term for this situation is a positive 4. If that number was a negative, we would write a negative whatever number it is. But anyways, that's the equation. And that equation is what we're going to use to find the 15th term. All right, so what I'm going to do now is I'm going to take this 15 because, well, the top up here is my x values. The bottom row down here is my y values. So these are your x's. These are your y numbers. If you plugged, 1 in, I'd get 7 for y. If I plugged a 2 in, y would be 10. So when I plug in 15 for x, so it'll go right in here, I'm doing 3 times 15 plus 4. All right, and then all I'm doing is solving. All right, so I'm going to solve for what y is. 3 times 15 is 45, plus 4 is 49. So when x is 15, y is 49, what is the 15th term? 49 is the 15th term. All right, now I actually want us to go back a page on 158. At the very bottom, they have a couple sequences. And the sequences are written right here, 10, 11, 12, 13, and then 5, 10, 15, 20. All right, so we're just going to use those sequences to write equations. We're going to get good at writing these equations, and then we're going to just make up an example, basically. So the first thing you want to do with any sequence of numbers is label them. All right, so we're going to put these in a table. 5, 10, 15, 20, and then 10, 11, 12, 13, right? It's the first, second, third, and fourth terms in the sequence. And again, we're going to use this base formula. It's called y equals mx plus b. Now in the book, you're going to see t equals, well, you'll see instead of x and y, they'll use n and t. But don't be confused. It's the same thing. They're just using different letters. So we're going to use this formula. Again, we want to find an m for both and a b for both. So let's start with m. M is whatever we get here. What is the pattern? Well, it's going up 1 every time. So m is 1 for this side. On this side, this is going up 5 every time. So m is positive 5, right? Again, if it was going down and subtracting the same amount, then we would write a negative number there. The next thing we're finding is b. And again, b is the 0th term. So that means I'm going to make a 0 here and here. What number would go in each situation? Well, this one would be a 9. So b ends up being 9, positive 9, by the way. And in this case, if you went backwards 5 on the other side, this would be a 0. So b is a 0, and you could say plus or minus for 0, doesn't matter. But that's part of the formula. The x and the equals and the y, they just get added. So here's what you've got. You've got this equation is equal to this sequence. This equation is equal to that sequence. And, we can write this another way just so we're clear. 1x is the same as x. So you could actually just write y equals x plus 9. Over here, when it says plus 0, you don't have to write that in a final step. You could just write y equals 5x. All right, so that's the equation for both. One of the things you got to get good at is writing that equation. And let's just say that both of these are asking for the, and we're just making up a number here. Let's say they're both asking for the 25th term. All right, so what number would be out there at the 25th number? All right, that's what we're basically saying. And what I don't want you to do is just keep adding the same amount until you get to the 25th number. I want you to learn this shortcut here. So all we're going to do is plug in the 25 in to the equation. Y equals x plus 9, so x is 25 in this case. So the 25th term for here is 34. And the 25th term here, I know that's hard to see, we plug in 25 in there, 5 times 25, y equals 125. All right, so the 25th term in that one is 125. All right, that's just an example. It's not really asking us to do that in that example, so we just kind of made it a little bit more to it. All right, example 3 on page 159, and you can read it along with me. It says the diagram shows the number of square tables needed to seat 4, 6, or 8 people at a restaurant. how many tables are needed to seat 16 people? All right, so T stands for tables. P stands for people that can be seated. And you can look at the drawing. For one table, there's 4 people that can sit there. When they have 2 tables, 6 people can sit there. When there's 3 tables, 8 people can sit there. So what it does is creates a sequence. Hopefully you're noticing that. So in this equation, here's what we're going to do. Basically the T for the tables, guys, that's the same as saying X. And the number of people, that's the same as saying Y. So just to not make this confusing here, I'm going to use Y equals mx plus b. All right, X is always the first, the second, the third, fourth terms in the sequence. And so I'm going to find a number for m. Again, m is this common difference. It's going up 2 every time. I always write y equals an x. And then b is the 0th term. So if I did 0 tables, that's kind of what it's saying, although that doesn't make much sense. 0 tables, if you just went backwards, there would be 2 people that could sit at 0 tables. Again, that doesn't really make sense, but for part of the sequence, that's helpful to writing our equation. For the 0th term, because that's what we're trying to find here, the 0th term, b would be positive 2. All right, so that's my equation. Now what I end up doing is, this is different than the other examples. This time I'm going to plug the number in for y, because this says how many tables, t, which is the same as x, how many tables would be needed to seat 16 people. So in this case, you're doing the sequence, but this time we don't have the x value. We have the y value, and we're solving for the x. All right, I know that might be confusing, but it's just one where you've got to work it backwards. So instead of plugging the number 16 in for x, I put it in for y instead. So now I've got 16 equals 2x plus 2, and I'm going to solve for x. Label your v's and c's here. 16 minus 2, I get 14 equals 2x. And of course divide by 2, so x, 2's cancel out, x equals 7. So that's what you get. 16 people, you would need 7 tables to seat 16 people. All right, guys, that's the end of the examples. Best of luck.